Hello, and welcome to Jackson Duenas and Simon Moo's Farm Physics. Today we'll be talking about projectiles and circular motion. We'll start with projectiles. With projectiles, you have an x-plane and a y-plane. You have an acceleration, an initial distance, a final distance, an initial speed, and time. Now all of those components apply to both your x-plane and your y-plane, and each of them will be different except for your time, which applies to both your x-plane and your y-plane. Let's say I throw something from the top of this tree, which is 10 feet tall. My initial x would be, in distance, would be 0 because nothing has moved so far from this beginning point. But my initial y would be 10 because I'm starting at 10 feet in the air, because y is vertical. My y final, we know that if I threw something off of this tree, would be 0 because it will hit the ground, and at ground y would be equal to 0. Now our final x in distance we do not know yet, because that is something we would have to calculate for. Let's say I threw something straight out at an initial speed of 10 meters per second. Then, using one of our formulas, xf equals xi plus vi times time plus half acceleration times time squared, we can find out any missing components we have. For our y-plane, acceleration will be negative 9.81, and for our x-plane, acceleration will be 0. Once you find out time using the y-coordinate, you can then plug time into the same equation, the xf equals xi plus vi times time plus time squared times acceleration, 1/2 acceleration, and then you could find out how far you threw an object or where your object landed at a certain time. Next, circular force. If I have something in front of me spinning in a circle, at the bottom of this, if I have a ball like swinging on a string in front of me like this, at the top of the circle, to find out the total amount of force, you'll have the force of gravity plus the tension on the string of this ball I have. And that's because both of those forces go inward, since the force of gravity always goes down, and the normal force, or the tension in this case, always goes inward. Since they're both going the same way, you would add those forces and set it equal to mass times acceleration. At the bottom, you would have tension, or the normal force, minus the force of gravity equals mass times acceleration, because the normal force still goes to the inside where the string is, but the force of gravity still goes down, so they oppose each other. To find the acceleration using circular force, you do the speed squared over the radius, and the radius is half the diameter, or the total length of the string, since the string will only go half of the circle. Thank you very much, and I hope you learned from this video.